So today we'll be performing Dijkstra's algorithm for graph search. In this experiment, we'll be performing two different approaches. One is we will be developing a MATLAB code to perform Dijkstra's algorithm for graph search, and there we'll be visualizing two different cases. And the second approach is we will be performing some other thing, like suppose a Python code for getting this Dijkstra's algorithm for path planning. Okay. So first of all, to perform this lab, we have to download the lab manual. The lab manual is provided over here. The link I'll be giving in the description of this video. So this is the lab manual. In that, you have a PDF file which I'm showing you right now, and the starter code file in which you have two different files like Dijkstra grid.m and test script Dijkstra.m. So these two files you have to import in your MATLAB. Over here, I'll show you, this is my MATLAB. Over here, I have imported these two files, and what I have to do is we have to make the changes in the Dijkstra grid.m file. So here you will be writing your own code to develop the Dijkstra's algorithm, and then in the text script Dijkstra, that file you will run it to visualize the output. Okay, we'll just read out the instructions that have been given in the lab manual. This tells you more about the MATLAB code, and you have to modify the Dijkstra grid.m file. In that you have to write your own code, and also over here there's a link which is provided. We'll go on to that link, and here we can see that we have more information about the algorithms, path planning algorithms specifically. This link actually has many interactive animations, as you can see over here. Now see, I've placed this endpoint over here. There is no path between the start and the goal, but now as I'm moving this endpoint, then we can see that the path is coming. So there are so many interactive animations over here in this file. We can just start the animation play, and you can find that the cost function is being calculated over here, and eventually the path will be found by calculating this cost. So like this, we can see this is a more good visualization of that. Some code snippets like pseudo codes have been provided over here, which you can refer specifically for path planning. And then let's move on to the Dijkstra's algorithm that they have provided. So this particular code gives you a reference to how you can develop your Dijkstra's algorithm path search code, and over here you can visualize through the animation, other animations as well. So this is about this side. Now let's go to MATLAB and visualize how our case will run according to the code that we have developed. Here we can see that Dijkstra grid.m is the file, and this part, as you can see over here, this is the portion wherein we have to add our own code so as to develop the Dijkstra path planning algorithm over here. Now this is the text script Dijkstra.m file. I'll just run this file and let's see how our animation will look like. See, we can see that the algorithm is trying to find out the path by avoiding the obstacles over here. So after the development of code, you will find such kind of outputs. Now let's visualize case 2 of the output, how it will look like. Now here in case 2, I have added more obstacles and made the path more difficult for the algorithm, but still it has found its path. You can see the animation like this. See, it's calculating the cost, and finally it is finding its path towards the goal. So this is how we have done the two different cases in MATLAB. Let's see how those two cases in Python will look like. So let's go to the terminal. So now this is the terminal, and I have typed the name of the Python file that I have created, which will find the Dijkstra's path planning algorithm path. So for this file, what I have done is, here I have visualized three different cases. In the two different cases, first cases, I have placed no obstacles in between the goal and the start point. And in the second case, I have placed many obstacles. See, this is the first case that you can see on the screen. The cost function will be calculated over here and the path will be found. And the third case that I have visualized over here is about a great obstacle because of which the entire field is getting separated in three points. So you will be seeing that. So let's see, the animation is quite slow, but you can visualize how the cost is getting calculated. So here, up till now, half of the cost has been calculated by the algorithm, and then the now cost calculation is almost done, and we can see that the goal point is under that. Like the cost calculation has covered the goal point as well. So now finally it's time to, yeah, see, we can see the message goal found. So now the path towards the goal will be shown by the code. See over here, we can see that the path is moving forward. So this is how the path for phase 1 has been calculated by the algorithm. It's moving towards the goal. We remember that we had our goal in this particular cell over here, and finally it has reached its path now. Now we can visualize our second case. See, now this is loading the second case. Over here we can see that we have placed obstacles over here. This is a big block of obstacle. The field has been entirely divided into two parts. Like this color, you can see this is the color of the obstacles that we have placed. Now the cost calculation has started. So here is our start point and here is a goal point. And this is the only area that is left for the algorithm to calculate the cost, and it will calculate it accordingly. So the cost calculation is almost done now in this case. And now the path will be shown, what path they have got in this particular case. So the goal found message has been printed over here. We are visualizing this particular thing in matplotlib, which is library of Python. And see the path is now being visualized, which will come towards the goal over here. Yeah, so the path is moving over here. Now it will move towards the right and probably towards the goal upwards. Yeah, so you can see how the path is moving. The goal is there in this particular cell over here, and our starting point was set over here. So the path from the start to the end point, that is the goal point, is in this format, as you can see in the animation, which is uh, given by the code over here. Okay, so now we can see that it has reached its particular goal. So this was all about the second case that we have visualized. Now we'll be seeing the third case. The third case, as I earlier told, here there is no way that we have kept for the algorithm to reach from the start point to the goal point. See that big obstacle which we have placed is in between both of these points, right? So the entire field has been separated into two different parts. Okay, so still the algorithm will try to calculate the cost, which is from the start point, and it won't be able to come towards this second part because it is being restricted by the obstacles. So whatever cost it will calculate, all those will belong particularly to this area itself, and no path can be found by the algorithm in this case. Now we can see that the cost calculation is complete, but however, it has not found any path to the goal. and that's why the no path found message has been printed over here. So in this way, the entire Dijkstra's algorithm path planning process we have done successfully implemented using both MATLAB and Python as well. Thank you.